Hello everyone, this is Sai Sri and welcome to my channel. In this video, I will explain an important question for IPE point of view from physics second year current electricity lesson. So state the working principles of potentiometer. Explain with help of a circuit diagram how the potentiometer is used to determine the internal resistance of the given primary cell. So this question is very important because it is repeated in March 15 for TS in 17 and 20 and AP 20 for 8 marks. So they asked to write the first of all working principle. So working principle is the potential drop across any portion of the wire is directly proportional to the balancing length of the portion. So potential drop, that is voltage, is directly proportional to length of the wire when the condition is uniform cross-sectional area. So cross-sectional area should be uniform. For example, if you take a pen, so this should be, the width should be constant or uniform throughout the wire. In constant current, so constant current is passed through the wire. If it is 20 ampere, till the experiment goes on, we have to use only 20 amperes. So in that way, constant current in the wire. So that is V is directly proportional to L. To take out the proportionality symbol, V is equal to pi L. So here it is potential gradient. We can also write the theory part for this. So from Ohm's law states that voltage is directly proportional to current. So that is from Ohm's law, potential across the wire at any portion of the balancing length L. So V is equal to IR from Ohm's law and R is equal to rho L by A. Rho means resistivity of wire. We also know phi means potential gradient, I means current flowing. So here IPA. So in place of IPA I am writing phi. So V is equal to phi L. So this is which we got, that is working principle of the potentiometer. Circuit description is not necessary to write, but for better presentation I am telling you. The first one, in potentiometer 10 meter length of magnet wire is fixed on 1 meter length of a wooden plank. So we have to take a potentiometer that is made up of magnet wire, magnet material, which is about 10 meters. And we have to fix a plank, wooden plank and a meter scale to measure the balancing length. So this is the circuit description. Now let us see the experiment. In the question, they asked to explain with a circuit diagram. So we have to draw the diagram very neatly. So the heading, to find internal resistance of a battery. So this is the diagram and we have to label the parts. So J means jockey, G means galvanometer, HR means high resistance, R means rheostat, primary cell, EMF of cell, K1, K2, K3 are flux keys, L1 is balancing length. So this is made up of magnet wire. So this is the diagram which we have to draw. Now experiment, what we have to do with the circuit. So case 1, first of all we have to close the key K1. So close K1 and open K2. And the balancing length of the wire L1 is determined by moving jockey J on potentiometer, touching at various points until the galvanometer showed null deflection. So to get balancing length, the principle is V is directly proportional to L. L means balancing length. So to get the balancing length, we have to move this jockey on various parts of this potentiometer, this wire. On various parts we have to move. On certain point, at certain point, the galvanometer shows null deflection. So there is no deflection in the galvanometer. Then we have to measure the balancing length. In that way we can find the balancing length. So after finding it, we can see that E is directly proportional to L. E means EMF. So here see, E means EMF, it is a cell and it has some internal resistance. Let it be R. And here it is the resistor resistance. We can connect bulb, fan, etc. So simply a small LED bulb. So here we have internal resistance. When we close this K1 and open this K2, the internal resistance doesn't work. So EMF works. Only EMF works when we doesn't connect a resistor. When we connect a resistor, then terminal voltage come into play. That is the point which we have to remember for this question. So when we close it, we can get EMF which is directly proportional to length L1 or L. Next, case 2. The case 2 is we have to close both K1 and K2. Now what will happen? The energy given by the battery will used by the resistor or the bulb, and it uses. So then the EMF turns into terminal voltage. That is the point which we have written. So EMF is converted into terminal voltage. V is directly, again we will measure the balancing length by moving the jockey on various parts. So that is V is directly proportional to L2. So let it be equation number 2. This is equation number 1. This is equation number 2. Now equation 1 is this, equation 2. Equation 1 by 2. So E by V is equal to L1 by L2. So we know that E is equal to IR plus IR. This is internal resistance. It is the resistance of a resistor from Kirchhoff law. And another one from Ohm's law, V is equal to IR. So in place of EV, I am writing this. Now take out the LCM. IR by IR, IR by IR. II cancel. So this is 1, 1 plus II cancel, R by R, L1 by L2. So send this 1 this side, then we will get L1 by L2 minus 1. Take the LCM L2. So L1 minus L2. And we want internal resistance. Internal resistance means smaller. So smaller is equal to, here it is dividing. When it go to this side, it will become capital R. So L1 minus L2 by L2. This is L. So L1 is balancing length of case 1. This is balancing length of case 2. This is external resistance, means bulb, which we have supplied. R is internal resistance of a given cell. So I am also writing the precautions which are not necessary for examination point of view, but for better presentation I am telling you. So the precautions are, for better presentation I am telling, no need to write. Jockey should not be dragged along the wire. The current value should be as small as possible. Current should be passed only while taking the reading.